Welcome back. A border has been created around normalized space. Keep in mind we are using a margin. Normalized space is completely tiled with hexagons. And along the edges, the hexagons are clipped so that they do not expand outside of normalized space. I'm going to be talking about the clipping in the next video, but in this one, I'm going to concentrate on the geometry of getting the edges of the hexagons to merge with each other. The hexagons are created by evenly spacing 6 vertices around the circle and interconnecting those vertices. Horizontally, if you space 2 polygons 2 radii apart, there's a gap. And there is necessary to close that gap to merge the right-hand edge with the left-hand edge of the other polygon. Also, if you directly place a polygon below a polygon above it, the 2 vertices will intersect if the distance between the center points is 2 radii. However, there's a need to slide the polygon up and over for the appropriate edges to intersect with each other. Okay, what is shown is a hexagon with its outer circle. There's a center point C and there's a radius R. There's a point Q which passes through an edge. The edge is AB. There's line segments from A to C and B to C. Now the distance between C and Q, you can take a look at the first equation here. The left-hand side is vector notation. In other words, if you subtract a point from another point, you end up with a vector. It's a direction and distance. If you take the absolute value of that, at least in vector notation, that's the distance. That is equal to r times the cosine of 30. That comes from basic trigonometry of a right triangle. Now, the distance between A and B, well, that's twice the distance between Q and B. So back to trigonometry, 2 times r times the sine of 30 degrees. Now it turns out that the sine of 30 degrees is 0.5, so what ends up happening is an edge is the same length as the radius. Now in terms of the length between C and Q, that value is important in terms of merging 2 hexagons horizontally. That'll be shown later. Now at the bottom, there's a 30-degree angle. That's the angle between the edge and a horizontal. Okay, we're back to our matrix of hexagons. I have center points C1 for C4. The edges of C1 and C3 have to be merged. C2 has to be positioned, has to be moved over and moved up. And C4 needs to be placed below C1. Let's do that first. We had indicated that the length of an edge is the same as a radius. We have a radius between C1 and the bottom of that hexagon, a radius between C4 and the top of that hexagon, plus an edge. So if you look at the equation down at the bottom, we have C1y minus 3r, because you're heading down. In the downward direction, it's towards the 0 point of y. Now, in terms of the x-axis, you're in the same position. C1 and C4 have the same x component. Now let's move on to merging C1, C3. All right. Indicated the distance between the center point and the intersection of the radius with an edge is r times cosine 30. Now we want to have to take into account that there's two cases of that. There's one for the left-hand hexagon and one for the right-hand hexagon. So you want to take C1x and you want to add the distance to r cosine 30 to get the C3x component. The y component is the same. They're on the same y value. Now, in terms of shifting, let's say shifting C2 up, if you placed, you see the diagram to the left of the top equations, if you place a hexagon directly under another hexagon, that would be the y value minus 2 radians. But we want to shift it. We want to move the y up. And we do that by moving it radius times sine of 30 degrees. Now you also want to move x over. You want to subtract in that direction. And you want to do that by the radius times cosine of 30. Let's go to the code. In any tiling endeavor, there's always a choice of the size of the tile relative to the space that's being tiled. That will determine a few things. It'll determine the number of tiles that end up being used. It'll also determine how much clipping there is on the edges. Now, in the case of rectangles, you could potentially have a rectangle that ends up with a perfect fit for the space, and there'd be no clipping. It wouldn't be the case in hexagons. You also have to make a decision as to the positioning of the first hexagon, because that would affect the amount of clipping on each side. You want to try to keep it even, okay, for reasonable appearance. Then you have the number of rows and the number of columns that are necessary to actually completely fill the tiling. Now, in my case, things are a little different because one row is really two rows because it includes a top row and an offset row that's merged into the previous row. There's some equations which we discussed or went over in quite a bit of detail. There's an x offset which takes care of the merging of a right-hand edge and a left-hand edge. And there's an x2 and an xy offset that take care of the sliding up of the underneath hexagons to merge them together. Now we're in the object-oriented world. There's a class called hexagon. In this case, I'm instantiating an object called hex. Now what that is basically a template. In other words, it's a certain size, radius, and it's a certain orientation. It's a hexagon with a vertex at 90 degrees. So in other words, the left and right side are verticals. This object, hex, is moved around to different center points and essentially told, draw, produce the lines. And you'll see that in very shortly. There's a loop for rows, and there's a loop for columns. Now, each time I go through a row, I have to determine where I'm starting from. In other words, what's my x and y? All right, now I'm starting the row is always the same. It's at x start. But y is a little bit different because I'm actually moving down the space. Okay, now we discussed this earlier, but it's 3 times the row number times the radius. And that's that 3 radii down for the next beginning row that I had showed you. I want to deal with the hexagons that are below, the ones that are offset. So I have a y2 and an x2, and I'm using the appropriate offset, which is calculated earlier, in the earlier equations. Now at this point, I want to simply start producing the columns. In other words, I want to form the row. I want to move through the columns. And I want to create a center point for where I am currently. And I want to draw the lines. So I said hex.draw at this center point. Now I want to create, at that point in time, another hexagon, which is the offset hexagon. So that's x2, xy, draw the hexagon. Now I want to move both x's. So I'm simply using the offset twice. I'm using it for x2, and I'm using it for x. That's all the code. In the next episode, I'm going to be discussing the line clipping algorithm. And the one following that, I'm going to be talking about the creation of simple polygons based on the object-oriented technique which was mentioned above. Have a good day.